In this module, we will discuss factors to consider when trying to determine if your results are meaningful, including issues related to sampling, reliability, and validity. Before we talk about sampling, we need to define what a sample is. First, let's define population. A population is an entire group of people who share some characteristics. For example, all fourth graders in Texas or all teachers at a specific alternative high school in Pasadena could be populations. Note that the size of the population doesn't really matter. What matters is that the population includes everyone who meets certain criteria. A sample is a subset of the population. All members of the sample should meet the criteria, but the group only includes some, not all, of the population's members. For example, out of all Texas fourth graders, a sample might be drawn of fourth graders at ABC Elementary School in Houston. Similarly, out of all of the teachers at XYZ High School, a sample of 5 teachers might be chosen. As noted before, a population is not defined by its size. Even a single class of students can be a population. Rather, the population is the group the researcher wants to draw conclusions about. If the researcher only wants to draw conclusions about his or her class of students, the class would be the population and the entire population would be studied. In traditional research, samples are almost always used, and researchers try to draw conclusions about the population based on the sample. In action research, it is quite common to study a small population, for example, a class of students, and just draw conclusions about that group. Both methods are helpful, and the choice of method heavily depends on the researcher's purpose. A teacher engaged in action research might want to find the best way of teaching his or her students, and it might not matter if the best way would apply to other classrooms or not. If a sample is well selected, the results will be generalizable to the population. This means that the results found in a study of the sample are representative of what might be seen if the entire population could be studied. Larger samples are more likely to reflect the entire population than smaller samples. Here is an example. If we have a population of 1,000 students and we randomly select 50 students, it is likely that these 50 students would be somewhat similar to the entire group of 1,000 students, but there's also a good chance that we will have selected students who stand out from the population in some way. For instance, this small sample might include a higher percentage of students labeled gifted and talented than the percentage of GT students in the entire population. As the sample gets bigger, 250 students, we are much more likely to have a representative sample. Here, a full quarter of the population has been chosen, which means that although there is a small likelihood that we have an atypical sample, the odds are pretty good that our sample will generally look like our population. Here, the sample of 900 students is almost identical to the population of 1,000 students, as practically the entire population is in our sample. It would be extremely unlikely to have a sample that is not representative of the population when the sample is this large, relative to the size of the population. In short, the bigger the sample, the more representative it is of the population, and thus the more likely we are to conclude that results obtained in the sample are generalizable to the population. Now let's talk about sampling. Sampling involves selecting participants from a population. There are 2 types. Random sampling, as the name would suggest, involves randomly choosing people from the population. In this type of sampling, all individuals in the defined population have an equal and independent chance of being selected for the sample. Random sampling is the best way to obtain a representative sample. However, it is pretty rare in educational research, as we often don't have access to the entire population. Furthermore, even when the population is accessible, members of the population could choose not to participate, which detracts from the randomness of the sample. The other type of sampling, non-random sampling, involves choosing participants either because they are available, called convenient sampling, or choosing them intentionally, called purposive sampling. Much educational research involves convenient sampling, which is understandable. However, we should keep in mind that a convenient sample is less likely to represent the general population than a truly random sample. Purposive sampling is most appropriate for qualitative studies, where the researcher wants to ensure that participants have the necessary experiences and/or characteristics and will be useful sources of information. Sampling error is chance variation that occurs when a sample does not represent the population. Sampling error is inevitable, as a sample can never match a population exactly. Sampling bias, however, is systematic sampling error. Bias, although unintentional, can be common in non-random sampling. For example, in a study of principals' opinions of effective leadership styles, sampling bias may occur if you sample principals at a leadership conference. When the results are obtained from a sample, the researcher has to determine whether the results are likely to reflect the results that would be obtained if the entire population had been studied. This process involves inferential statistics, as it requires the inference that whatever is seen in the sample would probably be seen in the population. Inferential statistics are based on the idea that sampling error will always occur, and that occasionally a sample will show changes or effects just due to chance. That is, the result is not a real result that would be obtained if the whole population were studied. Inferential statistics involve calculating the likelihood of getting a result, that is, change, difference, or effect, in a sample if no difference existed in the population. If the likelihood of this is small, the researcher can conclude that the sample result would probably be seen in the population. As noted before, purposive sampling is quite appropriate for qualitative research. In qualitative sampling, a small number of participants are selected that will be good informants. Good informants are thoughtful and reflective. They communicate effectively, and they are comfortable with the researcher and within the research site. Although qualitative samples are smaller and less representative, generalizability and representativeness are not the same concern in qualitative research as they are in quantitative research. More important is the researcher's ability to tell a story about the participants' experiences based on the data obtained. So, let's say you have a sample, whether obtained randomly or by convenience. Now what do? Well, it's time to collect data. Surveys are just one way of collecting data. Other methods include tests, rating scales, and other instruments or measures. The data are only as good as the measure. Measures that are reliable and valid will generally yield more meaningful results. Reliability involves consistency of measurement. Here are some examples. Every time the person takes the test, he or she gets approximately the same score. Two observers rating the same person give approximately the same rating. Two versions of the same test yield approximately the same score for the same person. Reliability is rarely perfect because of measurement error. No measure does a perfect job of measuring a construct. Validity involves accurate measurement. Valid measures have appropriate content, as judged by expert raters, for the construct being measured. For example, a test of student engagement should have questions about student engagement and not about other things. In addition to having appropriate content, valid measures should be related to other measures of the same construct and not related to measures of unrelated constructs. For example, a new IQ test ought to produce results similar to established IQ tests, but an IQ test score should not be related to measures of height and weight. Valid measures should also make accurate predictions. For example, a math placement test should assist in placing students into courses that best suit their needs. An invalid placement test would have high rates of misplacement. For example, good math students score poorly, or poor math students score well. How are reliability and validity related to each other? Reliability is a necessary condition for validity. Measures that are not reliable will not yield valid results. However, reliability is not a sufficient condition for validity. A highly reliable measure can still be invalid. For example, let's say you have a bathroom scale. Every time you step on it, it tells you that your weight is the same. This would be a very reliable scale. However, if the scale is consistently 5 pounds off, the weight would not be accurate. It would not be valid. Thus, although the scale is reliable, the results are worthless because it is giving you the wrong weight. To help produce meaningful results, it is important to create and use measures that are reliable and valid. Here are some guidelines to help you increase the reliability and validity of an instrument or a test that you create. Make directions and all test items clear. Have an expert review the measure. Adapt the reading level of the test to the expected reading level of the population. Ensure that scoring is objective. Standardize the administration of the test. Pilot test the measure to see if there are problems. And ideally, obtain more than one measure of the construct. By using reliable and valid measures, and by using an appropriately representative sample, your results will be more meaningful, whether you are drawing conclusions about just your participants or generalizing to the greater population from which they are drawn. One more thing to keep in mind. Although an appropriate sample and reliable and valid instruments do help to increase the meaningfulness of your research, meaningfulness is not just a question of how good your research is. It also refers to the so what factor of your results. For example, if your students improve on average 5 points on an exam, is that meaningful or not? Meaningfulness has to do with the context and the implications of the results. 5 points on a 10-question exam is pretty meaningful, whereas 5 points on a 500-question exam might not be. On the other hand, if an increase of 5 points represents crossing the line from a non-passing score to a passing score, that could be quite meaningful regardless of the number of questions on a test. Similarly, if an increase of 5 points represents the ability to communicate versus no ability to communicate, as might be the case with some students with severe developmental disabilities, 5 points would be extremely meaningful. As you learn about statistical significance in this course, you might be tempted to place great stock in whether results are statistically significant or not. The downside to this is that statistical significance is not synonymous with practical significance. You must always think through the implications of the results and determine whether your findings have practical relevance.